Hey everybody, this is Dr. Maples. We're going to get started on our sampling lecture series. Now, sampling is an important part of all the lectures that will come after this. So far, we've learned lots of basic stuff about conducting studies in terms of hypotheses and defining our variables and more. Well, with sampling, we're going to think about who we select to participate in our surveys and studies and interviews and so forth. And so sampling will be a part of all the assignments that actually come up after this in terms of the two methods assignments that you'll be completing. More about those at another time. But understand that sampling, even though it can be kind of boring, I understand, is an important part of making sure that we have good research design. Now, what I want to do is give you a basic example of sampling, something that demystifies the idea of sampling as being something that's complicated. And to do that, let's have pizza. Pizza is a classic way to think about sampling. Now, let's pretend that we go to our favorite pizza place, wherever that may be, and we order a large cheese pizza. And we have a group of 4 people, and so we order this large pizza, and when they cut it up, it's going to be split into 8 slices. Now, think about this. How many slices of that pizza would you need to eat before you could tell me with some level of confidence, if your eyes were closed, that you were eating a cheese pizza? Let's pretend that I didn't tell you, in fact, that I ordered the cheese pizza, that I just said, hey, I'm going to order a pizza, and you're going to be blindfolded, and I want you to tell me what kind of pizza you're eating. How many slices would you need to eat before you could tell me that that was, in fact, a cheese pizza? That's sampling. In fact, you could probably figure that out within bites, if not by the end of your first slice, whether that's through texture, whether that's through the tastes of cheese or the absence of pepperonis, you'd figure it out pretty quickly. Now, if you had reason to think that maybe I was trying to pull a fast one on you and that part of that pizza, say half of it was pepperoni and the other half was cheese, maybe you'd need to take a larger slice or more slices just to make sure. Like maybe you'd need to take a sample from one side and then a sample from the other side to make sure that you really knew what kind of pizza you were dealing with. Again, that's sampling. We're making sure that what we're tasting is representative of what's actually there. Sampling is not a complicated idea, but it just has a lot of different ways that you can approach it and a lot of terminology. So as we work through these, be patient, try to understand how these work, and if you need examples, you're always welcome to write me, and also I'll provide examples as I go along. All right, let's get started. Now, first things first, when we conduct a study, we want to make sure that we talk to a very representative group of the people that we're trying to study. Let's pretend that I'm doing a study of Kentucky residents. To make sure that I understand how Kentucky residents feel, how many of them would I need to talk to? Well, there's like 3.8 million, there's a lot of them. There's more than 50. There's a lot of Kentuckians out there. And for me to talk to all of them, it's just not going to happen. It doesn't matter how many resources I had. Even the Census Bureau won't manage to talk to everybody because people are born, people die, people leave the state, people may choose to hide. There's all sorts of reasons why it's impossible to talk to everyone. What about even in a smaller thing, like say all EKU students? It's ridiculous to think that I'm going to get the nearly 15,000 students, as I recall, to all respond to a survey and chat with me or to do an interview with all of them. It would be difficult for me to get everyone in a class of 30 to complete an assignment and do some kind of interview or something like that. That's why we do sampling, because to be honest, if it's groups that big, we really don't need to talk to everyone. We're probably fine to talk to a much smaller representative slice of those people. You see my pizza references coming back already? Now, when we're thinking about that, there's some important terminology. Now, I want to get that terminology straight in your head so that you can remember it. The terms are population and sample. Now, a population is a group that you plan to study. It's that whole pizza, by the way. Population is the group that you're planning to study. So I'm doing a study of Kentuckians. Well, my population is Kentuckians. In fact, we could do a study of EKU students. My population would be EKU students. A sample is when I take a selection of those people and ask them to complete a survey, do an interview, or somehow give me data. Population is the whole. A sample is a slice. Population is the whole pizza. Population, pizza. Sample is a slice. Are you ready? Sample, slice. Isn't that amazing how that works out? Oh, those are the little things in life that make, well, everything worth living, right? No? Okay, moving on. We can edit that out. Now, when we're thinking about samples, we need to think about how representative our sample really needs to be. And this is the last slide in our mini lecture. We're going to keep this one short and sweet. We're going to break this up across multiple smaller lectures. First off, we want to think about something called being representative. We want to make sure that our sample represents the people that are truly in this population. Sometimes we know a lot about the people we're studying. For example, I can tell you the exact percentages for sex, race, income, education, and age for EKU students. We have all that data. So I could predict to an exact degree exactly who we would need to include in our study. But what about the studies that I'm doing on rock climbers? We don't know how many rock climbers there are. We really don't. We don't even know who they are until, of course, I did a couple of studies to learn about that. So we couldn't really be sure that our sample was all that representative. This is where we get into the realm of two different approaches to sampling that'll dominate the next couple of lectures that we talk about. That's non-probability sampling and probability sampling. Now, non-probability sampling, you might guess, is when we take sampling and we just do our best. It may be something where we just get the people who are around us. It may be that we don't try to estimate if this is really representative of the sample. We just do what we can for many reasons to get what data we can. In other cases, we do probability sampling, where maybe we know exactly how many people are in the population, the pizza, maybe who these people are, and so we try to get a very representative sample. In both instances, even though we may or may not have a representative sample, our hope is that with any sample, we can do our best to generalize the results to the entire population, or pizza. With a probability sample, we can be pretty certain of that if we have a great sample. With non-probability, it's not really something that we can really do. We would have to do more studies to generalize our results. Now, by generalize, I mean that we say if this finding applies to this group, then it should apply to similar groups. So, for example, if I do a study of climbers in the Red River Gorge, and I do a non-probability study where I interview 50 of them, my hope would be that I could somehow say that my results that I find from interviewing those 50 people could be generalized to all the rock climbers in the Red River Gorge. And I could even hope that maybe I could generalize my results on the Red River Gorge to all rock climbers. It's easier to make that argument when you have a probability sample, which is something that we can determine often statistically to know that it really represents the people that we're studying. So, representative means that the sample is representative of the whole. The slice that you eat of that pizza is representative of the whole pizza. Probability sampling helps us know for sure that we have a representative sample, whereas a non-probability sample, we just do our best with what we have. And then finally, we're hoping with sampling, but particularly probability sampling, that we can generalize our results. In fact, to go back to our pizza example one more time, we could hope that if we take one bite or one slice out of a cheese pizza and we eat that, we could say with 99% certainty that the rest of that pizza is in fact a cheese pizza. And we could hopefully generalize those results to all the cheese pizzas that they have there, because they would all taste like that. Now, what we're going to do in the next lecture is we're going to start breaking down non-probability and probability examples. This is where things, I'll be honest, they get a little tedious, because you remember, I took this class when I was an undergraduate as well. I know what you're going through on some of those things. Take your time through those. They're going to be shorter videos so that you can watch them multiple times, take good notes, because remember, you're going to need to apply some of these concepts in an upcoming methods assignment. All right, that's where we're going to stop for now. Now, if you got questions, if you need anything, you know where to find me. Drop in on office hours. Send me an email. I'm happy to answer questions. Otherwise, I'll see you later. Take care.